Question 49. Find the exact value of the following expression. Sine of 11 pi over 3 times secant of 4 pi over 3 times tan of minus 5 pi over 6. So there's two things that we want to be mindful of when we do this question. The first thing that we want to be mindful of is what quadrant are we considering, or what quadrant are each of these angles in. Because the quadrant determines the sign as to whether something is positive or negative. The second thing that we want to take into account is the reference angle. And the reference angle is very easy to find for each of these angles, and we will do that. The reason we use the reference angle is because the reference angle will help us get the ratio. We may recall our two special triangles, and I could see we only need the pi over 3, pi over 6, pi over 2 triangle because of given information here. So I'm going to draw my triangle. My angle here is pi over 6. My angle down here is pi over 3. And we will put in the ratios. Opposite pi over 3 is root 3. The hypotenuse is 2. And then opposite pi over 6 is a side length of 1. So we'll use all of these. So I'm going to go through each of the angles and determine which quadrant we're in. So 11 pi over 3 is the first angle that we're staring at. And when I think of 11 pi over 3, I want you to think that, well, 11 pi over 3, you could convert that to, degrees, but that takes a little bit of time. 11 pi over 3 is a little bit smaller than 12 pi over 3. And 12 pi over 3 is 4 pi. So if we are slightly smaller than 4 pi, let's think about where that is for a sec. If we're slightly smaller than 4 pi, let's just think about our place in the circle, right? One rotation is 2 pi. The next rotation would be another 2 pi. If we're slightly smaller than 4 pi, we're somewhere in quadrant 4. And in quadrant 4, so I'm just going to write quadrant 4 right here. And we have sine. All students take calculus. All students take calculus. This would be a negative ratio. Okay, so I'm going to go through that for all my angles, and then I'll get the ratios from the triangle. So 4 pi over 3. That one's a little bit easier to think of. 4 pi over 3, right, is a little bit bigger than pi, and we would have seen that one a lot. 4 pi over 3 then is quadrant 3. And 4 pi over 3 is quadrant 3. And if we think about tan being positive, secant will be negative. And then the last angle, I'm going to have to write that up here somewhere. The last angle is negative 5 pi over 6. So we're rotating in the negative direction. We're 5/6 of the way to pi in the negative direction. So we're not quite there. Okay, so pi would get us back to 180 degrees, of course. But we're not quite there. Negative 5/6 of the way there. This is also quadrant 3 as well. So our quadrant 3 and tan in quadrant 3 is actually positive. So we want to be mindful of that. So now we know what's negative and positive. Let's go ahead and use our triangle. So sine of 11 pi over 3, it's the same as the sine of pi over 3, except it's a negative ratio. So if we're at pi over 3, opposite over hypotenuse, of course, will give us a root 3 over 2. Remember that it's negative because of what we determined earlier. Now we're going to go to secant. I'm slow, so I always think of cosine first, because cosine and secant are reciprocals of one another. So if we go pi over 3 cos, it's 1 over 2. Because we're doing secant, it'd be hypotenuse over adjacent, it'd be 2 over 1. And again, we determined earlier that this is negative. So I'll just write down negative 2. And then lastly, we have tan. And our reference angle, again, is pi over 6. You know, as long as your angles don't reduce, like 5 pi over 6, your reference angle is pi over 6. It has to be a special angle as well. But so pi over 6 and tan 1 over root 3 because it's opposite over adjacent. And we keep that positive. So 1 over root 3. So you can expand this out however you like. I will just take care of the negatives. 2 negatives will give me a positive answer. And this root 3 will cancel that root 3. Oh my goodness. And this 2 will cancel that 2. So I believe all we're left with is 1. And that is our answer.